In the fall of 2017, something truly extraordinary happened. Something that shook the entire astronomical community and sparked debates that continue to this day. A mysterious object zoomed through our solar system at an unusual speed and angle, baffling scientists around the world. It was given a name that's become legendary in space exploration circles. Oumuamua, which means a messenger from afar arriving first in Hawaiian. But what exactly was this enigmatic visitor? Where did it come from, and why has it triggered such intense speculation? On October 19, 2017, the Pan-STARRS-1 telescope in Hawaii detected a fast-moving object that wasn't following the usual elliptical orbit typical of asteroids or comets within our solar system. It was instead moving on a hyperbolic trajectory, which meant it was not bound to the Sun and had likely entered our solar system from interstellar space. This was a groundbreaking discovery. It marked the first time we had ever identified an object from another star system passing through our own. Initial observations indicated that Oumuamua was unlike anything we had seen before. It didn't have the glowing coma or visible tail of a typical comet. Yet, it was accelerating in a way that couldn't be fully explained by gravitational forces alone. This non-gravitational acceleration sparked a flurry of theories and hypotheses. Could it be a comet releasing gas in ways that we couldn't detect? Or was it something entirely different? The object was also oddly shaped. Based on the fluctuations in its brightness as it tumbled through space, scientists estimated that Oumuamua was highly elongated, possibly cigar-shaped, or maybe even disc-shaped, with a length 10 times its width. It rotated every 7.3 hours, and its brightness varied dramatically, suggesting an unusual geometry. But without direct imaging, these shapes remained speculative. Adding to the mystery, Oumuamua didn't emit any detectable gas or dust, which would be expected if it were an icy comet being warmed by the sun normally. Such sublimation would produce a visible tail. Yet, despite sensitive instruments scanning it from Earth and space, none was seen. Still, its slight acceleration away from the sun hinted that some kind of outgassing might be happening invisibly. This paradox fueled both conventional and unconventional explanations. Scientists raced to gather as much data as possible before the object became too distant and dim to observe. Within a few weeks, it was already fading from view. Given its high speed, estimated at about 315,000 kilometers per hour, it was clear we would never see it again. That urgency added to the allure and urgency of understanding it. Some researchers proposed natural explanations. Perhaps, Oumuamua was composed of hydrogen ice, which could sublimate without leaving detectable traces. Others suggested it might be a fragment of a larger body that was torn apart near another star, flung into space by gravitational interactions. Another theory proposed it could be a shard of nitrogen ice, similar to Pluto's surface, ejected from a distant exoplanet. But then came the more controversial idea, the possibility that Oumuamua was artificial in origin. Avi Loeb, a Harvard astrophysicist, made headlines by suggesting that the object might be a piece of alien technology, perhaps a light sail or probe sent by an intelligent civilization. Loeb argued that the object's acceleration, lack of typical comet behavior, and extreme shape could point to something constructed rather than natural. The scientific community had mixed reactions. Many dismissed the alien hypothesis as speculative and lacking evidence, preferring more conservative explanations. But others appreciated the need to consider all possibilities, especially when dealing with an object so unprecedented. Loeb's theory sparked intense public interest and opened up discussions about how we define evidence in the search for extraterrestrial intelligence. Meanwhile, the debate over Oumuamua's origin and nature continued in scientific papers and media reports. Observatories around the world combed through their data archives to find any missed opportunities for observing the object. Amateur astronomers joined the hunt, and even SETI researchers scanned for radio signals, just in case. No signals were detected, and no additional objects like Oumuamua were immediately found. However, in 2019, a second interstellar object was discovered, Comet 2I/Borisov. Unlike Oumuamua, Borisov behaved like a typical comet, with a visible coma and tail. Its presence confirmed that interstellar visitors weren't as rare as once thought and provided a valuable comparison. But Borisov didn't have the same oddities that made Oumuamua so baffling. What we do know is limited but compelling. Oumuamua originated from outside our solar system, likely from another star system entirely. Its motion, speed, and trajectory made it clear that it was interstellar. It was about 100 meters long, possibly flat or elongated, and tumbling chaotically through space. It reflected sunlight in ways that suggested a metallic or icy composition, but exact materials remain unknown. In short, Oumuamua defied easy classification. It wasn't clearly a comet, asteroid, or spacecraft. It was something new, and that made it scientifically valuable. It reminded the world how little we truly understand about the universe and what might be out there traveling between the stars. Despite its brief visit, Oumuamua left a lasting legacy. It inspired new research into interstellar objects, led to proposed space missions to intercept future visitors, and reignited public interest in the idea of alien life. Scientists realized that we needed better early warning systems and faster response capabilities to study such fleeting phenomena. And perhaps most importantly, it made us question our assumptions. Could we really be alone, or had we just missed the signs? What other secrets might be hiding in the darkness between the stars? These questions set the stage for Part 2, where we dive into the legacy of Oumuamua, the latest theories, and what's being done to prepare for the next interstellar visitor. In the years following Oumuamua's visit, the astronomical community has not rested. New research initiatives, observational programs, and theoretical studies have all emerged, fueled by the urgency and mystery that Oumuamua brought with it. While the object itself vanished into the dark depths of space, its impact continues to ripple through scientific circles, redefining how we approach interstellar phenomena. One of the most significant outcomes has been the creation of dedicated search programs for interstellar objects. For instance, NASA and other international space agencies have begun investing in early warning systems that can detect fast-moving objects from outside our solar system. The goal is simple: spot them early enough to study them in real time with both ground-based and space-based instruments. Learning from Oumuamua's fleeting appearance, astronomers now understand the importance of speed when it comes to capturing data on these rare visitors. At the same time, proposals for missions that could intercept future interstellar objects are taking shape. One such project is the ESA's proposed Comet Interceptor mission, which aims to launch a spacecraft into a stable orbit and have it ready to rapidly fly by any incoming object. Similarly, more ambitious concepts involve using solar sails or nuclear-powered propulsion to chase down fast-moving targets like Oumuamua. Back on Earth, the debate around Oumuamua's nature continues. New research papers regularly explore various theories, ranging from exotic physics to natural explanations. One of the more recent ideas suggests that Oumuamua could have been a fragment of a Pluto-like exoplanet, composed largely of solid nitrogen. This theory gained traction because nitrogen ice could explain the object's acceleration without leaving a visible trail, aligning well with observations. Other studies have proposed even more exotic origins. Some suggest that Oumuamua might have been a sliver of an exoplanet destroyed in a violent supernova or a product of tidal forces from a massive black hole. Still, no consensus has been reached. Each explanation solves some mysteries but leaves others untouched, keeping the debate alive. Avi Loeb, the scientist who originally proposed the alien probe hypothesis, has not backed down. In fact, he has doubled down, launching the Galileo Project, a research initiative aimed at systematically searching for evidence of extraterrestrial technology. This project involves scanning the skies for unusual objects, using AI to filter out mundane phenomena, and even developing plans for new telescopes. While controversial, the project reflects a growing willingness in science to think beyond traditional boundaries. Loeb argues that science must be open to bold hypotheses, especially when confronted with anomalous data. He believes that even if Oumuamua wasn't an alien spacecraft, it proved that strange objects do pass through our neighborhood, and we should be ready to investigate them thoroughly. His project has attracted both support and criticism but has undeniably shifted the tone of discussions about alien life. Meanwhile, the discovery of Comet Borisov added weight to the idea that interstellar visitors are more common than previously believed. Astronomers estimate that thousands of such objects may pass through our solar system every year, but most go undetected. These are likely icy fragments, relics of planetary systems far away, offering a unique glimpse into the building blocks of alien worlds. The scientific community is now pushing for new surveys with next-generation telescopes like the Vera C. Rubin Observatory, which is expected to revolutionize our ability to detect faint, fast-moving objects. With its wide field of view and advanced imaging technology, the Rubin Observatory could potentially identify multiple interstellar visitors each year. In parallel, private companies and startups have begun exploring how to commercialize or participate in these efforts. Some envision mining valuable materials from interstellar asteroids. Others see opportunities for partnerships with space agencies in developing rapid response missions. What was once science fiction is now inching closer to reality. Oumuamua also raised important philosophical questions. How should humanity respond to a truly alien artifact? What if one of these interstellar visitors did turn out to be artificial? Would we recognize it as such? Do we have protocols in place for communication, analysis, or even contact? These questions are no longer purely academic. They are being actively discussed in international forums and among space policy experts. Even cultural and artistic communities have responded to the mystery of Oumuamua. It has inspired novels, films, documentaries, and countless speculative articles. Its story resonates because it sits at the intersection of science, imagination, and the unknown. It reminds us that the universe is still full of surprises, and we are only beginning to understand our place in it. As we look ahead, the legacy of Oumuamua is clear. It has forced scientists to expand their thinking, to develop better tools, and to prepare for the unexpected. Whether it was a comet, a shard of ice, or a probe from another civilization, its arrival was a wake-up call. The next time something comes speeding through from beyond the stars, we may be ready, not just to observe it but to meet it. And so, the story of Oumuamua continues. It may be gone from our skies, but it's embedded in our scientific memory. The quest to understand it has led to new fields of research, new missions, and a renewed sense of curiosity. Perhaps one day we'll learn exactly what it was. Or maybe, just maybe, it was the first whisper from a larger cosmic conversation waiting to unfold.